virtual series of the operating system. I am a instructor, Varshata. Let's start our lecture series. Today we are starting the new unit, that is unit number 10 from IT, that is approaches to the virtualization. So let's see. At the end of this video, you will be able to learn about the processor issue, then we will see the memory management, then we will see IO management, then VMware ESXi, and then we will see the ZAN. Now first is a processor issue. Okay, so this is the one of the issue in the virtualization. How this processor issue is managed? Processor issue, or we can say the CPU virtualization. CPU virtualization allows an operating system to more effectively and efficiently utilize the CPU power in a computer so that it runs faster. Because we have the virtual operating system as well as the host operating system. And if there is a single processor, then it should divide all the loads. So this feature is also requirements for the many virtual machine software and is required to be enabled in order for them to run the properly or even at all. Okay, so CPU virtualization goes by different names depending on the CPU manufacturers. For CPU, for the Intel CPU, this is referred as the Intel virtualization technology or Intel VT. And with AMD CPU, it is called AMD V. So based on the organization, it has the different names. Okay. Now let's see again the processor issues in detail. So regardless of what it is called, each virtualization technology provides generally the same features and the benefits to the operating system. Okay, main concept is what it provides the benefits to the operating system. Okay, whatever the name of that particular virtualization is, that doesn't matter, but the concept should be same. Unfortunately, in many cases, CPU virtualization is disabled by the default in a BIOS and needs to be enabled in order for the operating system to take the advantages of it. Okay, so by default this virtualization is disabled, but if you want to do the virtualizations of the operating system, then you should have to enable from the BIOS. Processor management responsible for the processor virtualizations, scheduling, interrupt handling, executions or the privileged operations, and the system calls and the multi-threading. So this processor management should be responsible for this. Okay, so for the processor virtualization, for the CPU virtualizations, everything that should be done by the processor management. Now next one is the memory management. Because of the extra level of the memory mapping introduced by the virtualization, EXI can effectively manage the memory across all the virtual machine. What is EXI? That we will see later. Okay, so this is extra level of the memory mapping introduced by the virtualizations. We have to maintain this virtualizations. Okay, so that should be done by the EXI. Some of the physical memory of the virtual machines might be mapped to the shared pages or to the pages that is unmapped or swapped out. A host performs the virtual memory management without a knowledge of the guest operating system and without the interfering with the guest operating system own memory management subsystem. Okay, so in memory management, virtualizations of the memory management, that means what? The host perform the virtual memory management. Everything is done by the host without the knowledge of the guest operating system. Okay, so whatever the guest operating system is, it doesn't know anything about this virtualization. Okay, that everything is maintained by the host operating system. Okay, so also without interfering with the guest operating system owns memory management subsystem. If you have installed one operating system on your host system, then also there is a memory management for the guest operating system, because you are executing the processes in the guest operating system also. So that should be a virtual memory management, and that should be done by the host operating system. Okay, the VMM, that is a virtual machine monitor. For each virtual machine maintains the mapping from the guest operating systems physical memory pages to the physical memory pages on the underlying machines. That means from the host operating system to the guest operating system, that virtualization mapping should be done, and that mapping is done by the VMM, that is a virtual machine monitor. Each virtual machine sees the contiguous zero-based addressable physical memory space. The underlying machine's memory on a server used by each virtual machine is not necessary that is contiguous. Okay, so it is not necessary that contiguous memory allocation is there. Now, the guest virtual to guest physical address are managed by the guest operating system. Okay, guest virtual to the guest physical address, that is done by the guest operating system. Here, the hypervisor is only responsible for translating the guest physical address to the machine address. Now here you can see this is the memory mapping diagram. The diagram illustrates the EXI implementations of the memory virtualizations, how memory virtualizations can be done. So here you can see the guest virtual memory is there, guest physical memory is there, and this machine memory is there. Okay, so this mapping is done by, so here you can see the arrow from this guest virtual machine to the guest physical memory. So that is the arrow that defines the virtual memory mapping using the page table. Okay, so and that is maintained by the guest operating system. From C to C, from B to B, from A to N, from B to D. B to B, that is maintained by the guest this mapping is maintained by the guest operating system using the page table. Now next mapping is the from guest physical memory to the machine memory, and next mapping is what that is shown as the dashed arrow. Okay, so this dashed arrow is showing the memory mapping from the guest virtual memory to the physical memory, and that is using the shadow page table. So let's see the description of this in detail. So here you can see the boxes represent the pages and the arrow shows the different memory mapping. So in this figure, in last figure that we have seen, the boxes represent the pages and arrow represents the memory mapping. The arrow from the guest virtual memory to the guest physical memory shows the mapping maintained by the page table in the guest operating system. Okay, so that is done by the guest operating system in the page table. Then the arrow from the guest physical memory to the machine memory shows the mapping maintained by the virtual machine monitor. Okay, so that mapping should be done by the virtual machine monitor from the guest physical memory to the machine memory. Now the dashed arrow shows the mapping from the guest virtual memory to the machine memory in the shadow page table, also maintained by the virtual machine monitor. VMM, that means virtual machine monitor. Okay, so these are the informations about the memory mapping in the guest and the host machine. Now next one is the IO management. IO virtualizations or the input-output virtualization is a technology that uses the software to abstract the upper layer protocols from the physical connections or the physical transports. Okay, so this technique takes a single physical component and presents it to the device as a multiple component. Okay, so because it separates the logical from the physical resources, IOV, that is IO virtualization, is considered an enabling data center technology that aggregates the IT infrastructure as a shared pool, including computing, networking, and storage. Okay, IO virtualizations can be there. Okay, so many IT infrastructures right now using the IO virtualization. They are using the virtual software, virtual PCs. Okay, right now because of this COVID pandemic, all the IT infrastructures, all the IT professionals are working from their home. So how is it this possible? Because of all such type of virtualization. Okay, now what is the hypervisor? Okay, so hypervisor is also known as the virtual machine monitor, we can say VMM, is a software that creates and runs the virtual machines. Okay, so if you want to install any virtual machine, you should have the hypervisor as a software in which you can install the virtual machine. Hypervisor also one host computer to support multiple. Hypervisor allows one host computer to support multiple guest virtual machine by virtually sharing the resources such as memory, processing. Okay, so all this shared as a virtualization, and you can install the guest operating system as many as you want. Now, why hypervisor is used? Hypervisor make it possible to use the more of the system available resources and provides the greater IT mobility since the guest virtual machines are independent of the host hardware. Okay, so this guest virtual machines are independent. Okay, so for example, admin had provided the different virtual machine to the different users. Okay, so if they have that physical operating system, that host operating system, then if admin want to interact with that operating system, then admin cannot directly interact with. But if there is a virtual machine, virtual operating system is that, then admin is seated at the remote place, then also that admin can access the operating system, admin can access the computer system of that particular user, because that is a virtualization. So this is the reason why we have to use the virtualization concept. This means that they can be easily moved between the different servers, and if the admin want to move that virtualization from one server to another server, then also it is possible, because multiple virtual machines can run off one physical server with the hypervisor. A hypervisor reduces the space, energy, and maintains the requirements. Now there are basically two types of hypervisor: hypervisor 1, type 1 and type 2. Okay, so a type 1 hypervisor acts like a lightweight operating system and runs directly on the host hardware, while type 2 hypervisor runs as the software layer on an operating system like the other computer programs. Now the most commonly deployed type of hypervisor is a type 1, or we can say it is also known as the bare metal hypervisor, where the virtualization software is installed directly on the hardware where the operating system is normally installed. Okay, so here virtualization software can be directly installed and in which you can install the operating system. So that is known as the type 1 hypervisor. Because bare metal hypervisors are isolated, okay, isolated from the attack-prone operating system, they are extremely secure. So type 1 is extremely secure because we can prevent it from the attacks. Here in addition, the generally perform the better and more efficiently than the hosted hypervisor. For this reason, more enterprise companies choose the bare metal hypervisor for the data center computing needs. Okay, so for the centralizations of the database, for the data security, type 1 hypervisor is used. Now next one is the VMware EXI. Now what is this? ESXi provides a virtualization layers that abstracts the CPU, storage memory and networking resources, physical host into the multiple virtual machines. This is also one type of virtual machines. Okay, so that means the application running in the virtual machines can access these resources without direct access to the underlying hardware. Okay, so application that is installed in this that can access directly. VMware refers to the hypervisor used by the VMware EXI as a VM kernel also. VM kernel receives the request from the virtual machines for the resources and presents the request to the physical hardware. Now ESXi is supported on the Intel processors or Zen and above and AMD operated processors. Okay, ESXi includes the 64-bit VM kernel and host with the 32-bit only processors are host with the 32-bit only processor are not supported. But both 32-bit and 64-bit guest operating systems are supported. Host should be 64-bit, but guest operating system can be 32-bit or 64-bit, both are acceptable. ESXi supports up to 4096 virtual processors per host, 320 logical CPUs per host and 512 virtual machines per host and up to 4 TB of RAM per host. Okay, ESXi can be installed on a hard disk, USB device or the SD card. It has the ultra-light footprint of the approximately 144 MB for increased security and the reliability. Now next one is a Xan. Xan is the open source hypervisor included in the Linux kernel and as such it is available in the Linux distributors. Okay, so Xan project is one of the many open source projects managed by the Linux Foundation. It is open project, or we can say it is an open source. A typical environment running in a Xan consists of the different parts. To start with the There is a domain 0 in that. This is how you can refer to the host operating system, or it is not really a host operating system in that sense. Other virtual machines, domain in a Xan terminology that we can say, and it don't have to use the get access to the host server or the hardware. Domain 0 is only responsible for access to the drivers, and if any coordination has to be done, it will be handled by the domain 0. Okay, so if any coordination is that will be done by the domain 0. Apart from the domain 0, there are the other virtual machines that are referred to as a domain U. That means we have divided different functionality in the different domain. Domain 0 is there, and if it other functionality is there, then we can say the domain U is there. Now, Xan offers the two types of virtualization, that is a para-virtualization and a full virtualization. Full virtualizations, all of you know that we have discussed. Okay, so para-virtualization, that means what, the virtualized operating system runs on the modified version of the operating system, which results in the operating system knowing that it is a virtualized. Okay, so operating system should have the information about that operating system is a virtualized. The only drawbacks of the para-virtualization is that the modified guest operating system need to be used, which is not provided by the many vendors. Okay, so here we have to use the modified version of the operating system that is not provided by so many vendors, so this is not more popular. The concept of the full virtualization, this is a virtualization mode where the CPU needs to be provide the support for the virtualization extensions only. In full virtualization, unmodified virtualization OSs can be effectively addresses the hardware. So here no any modification is there in the host operating system, just you have to install one software for the virtualization in which you can install the operating system. So in this video we have learned this topic, that is a processor issue, that we have seen the memory management, then we have learned what is how we are able to done the IO management, and then we have seen the VMware EXI and Xan virtualization software. The remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.